what we need to do to get through here. Okay, so for this one, the first problem is just a straight cross multiply and divide. We have 21 times, computer's not going to cooperate either, looks like. Okay, so there we go, 21 times 25, which is 525, and then divided by the 15, which is going to give us 30. Perfect, 35. Now that one we could do that straight cross multiply and divide. For 2 and 3, it's most likely easier if we cross multiply and create the equation. So we've got 19 times 50, which is 950, perfect. And then we've got 5x times 95, which is 475x. And we go to solve that, what do we have to do? Divide by the 475. So 2 equals x, or x equals 2. And this last one's probably the most difficult of the 3. We've got the 21 times 12, which is 252. Then going this way, we've got x plus 3 times 63. I'm going to write it out here. 63 times x plus 3. So the 252 isn't going to change yet. We have to distribute the 63. So 63 times x, just 63x. What's 63 times 3? Careful. 63 times 3. 189. So now we subtract 189. Perfect. So this is 63 equals 63x. And finally? Perfect. We divide by 63 and x does equal 1. Well, that process of setting up a proportion and solving is extremely beneficial. As we go through this unit even, like I said, we've got about 2 weeks left in this unit. Well, not quite 2 weeks left in this unit. But as we go through this unit, we're going to see several applications of solving these proportions. And we can even do it, we can even use it for our measurement conversions. If I happen to know that 1 gram equals 15 grains, if I needed to convert 8.2 grams into grains, I can use one of these proportions to do it. I have that relationship. 1 gram is 15 grains. And now remember, this is not a ratio, this is a rate because I have different units. I have grams here and grains here. And when I have rates, my other fraction, the other side of the proportion, must have exactly the same unit. So I have to have grams on top and grains on bottom. So now my 8.2 grams goes with the grams, and I am looking for the grains. So we will cross multiply and divide. 15 times 8.2 is 123, and of course divided by 1 is just 123. So it's 123 grains. Now at some point we're going to talk about dimensional analysis, which means you use the units as well. So this would be 15 grains times 8.2 grams. So that's going to be grains times grams. And then you divide by the 1 gram. So the 1 doesn't change the number, but the grams do divide out and gives us grains. So the units actually work out as well in that calculation. In our last unit, we talked briefly about percents. We converted between the different forms of percents, and we did our basic calculations of percents. And what we've looked at here with our proportions, we used a proportion to solve our percents before, but that idea of maintaining relationships and keeping things matched up is really what makes that proportion a useful tool with dealing percents. For example, let's say that LFB Corporation estimates sales expense as 8% of gross sales. What were gross sales for a day where sales expense is estimated at $12,000. So as we saw before, we have that percent. We have the 8%, which is 8 over 100. And we talked about how the 8, the number that's actually given with the percent, represents a portion or a piece of interest. It's what we're focusing in on. And the 100% represents the whole amount, or sometimes the starting amount or the beginning amount. And the 8, whatever the 8% is focusing in on, has to be part of that. It must come out of that 100%. So it's a piece within that whole amount that we're focusing in on. If that 8 is not from within that piece that is represented by the 100%, then the percent itself doesn't apply. So here, on the other side, we have the $12,000. Does that represent, well, in this case, the 8%, the portion of interest, represents sales expense. And that sales expense is a portion of the gross sales. So that $12,000 that we have here, does that represent the sales expense or the gross sales? Well, it says sales expense is estimated at $12,000. So that $12,000 represents the sales expense. That's what were the gross sales. So that's what we're looking for, is gross sales down here. So now we can find that number by cross multiplying and dividing. 100 times 1,200 divided by 8 is going to give us 150,000. So we saw basic problems like this a couple weeks ago in Unit 1. What we want to focus on today is increase and decrease problems. So let's say that last week we had 820 critical care patients. This was a decrease of, oh, let's see, what do I want to put in here? Let's say this is a decrease of, we'll just go 5% from the previous week. How many fewer patients were there? How many less patients, how many less critical care patients are there this week compared to last week? So we've got to ask ourselves, we have that 5%. And that 5% is the decrease in our patients. The 820 here, of course, is this week. And we're looking at last week. We need to know which one of those numbers is represented by that 100%, this week or last week. Well, remember we said the 100% is either the whole amount or the beginning amount. So the beginning amount would be last week, the previous week. Oops, I should be careful. I'll just call it previous week so that I don't have my wording confounded there. So the previous week, the first week is what we're looking at there. Well, the 820, that's this week. That's what we have right now after the decrease. So the 100% does not represent the 820. So what we have to do is this. If we started out with 100% and we had a 5% decrease, that means what we have right now is 95% of the patients that we had during that first week. So what we're looking at here is not a 5%. We're not looking at the increase directly. We need to look at the 95%. So 95% is current week, and the 100% is the previous. And the 820 patients is in our current week after the 5% decrease. So we can cross multiply and divide 100 times 820 divided by 95. Gives us 863.2. So now since we can't have a tenth or 2/10 of a patient, we're going to round that to 863 patients. So we had 863 patients last week, 820 this week. Now we are looking for how many fewer? How big is the decrease? So 863 minus 820. That's 43 fewer patients. So when dealing with these percent problems, we really do have to be very careful about making sure that the percent that we're using matches up with the number that we're applying to it. Just like we were saying with the other proportions. Whatever goes here has to have a relationship with what's here. The same here. Whatever goes here has to have a relationship with what's here. Let's say that a doctor orders a dosage increase for a patient. So a dosage increase of 15% to 920 milligrams. What was the previous dose? So again here, I'm going to actually make a table here that the table tends to help me think things out. So what I'm going to do is this. We had a previous dose. And we added an increase. This is an increase, so we are adding here to get our current dose, or our new dose, whatever we want to call it. As we've mentioned before, in these percent problems, every item in that problem is described by a percent and by another number. In this case, it's going to be milligrams over here. So what do we know for percents? Well, we have the 15%. That's the percent of the increase. But we know that the beginning amount, or the previous dose, would have been 100%. So if we're adding 100 plus 15 means the new dosage is 115% of that previous dosage. For the numbers, we know that 920 milligrams is that new dosage. Now here we are looking for what was the previous dose. So we are looking for this number right here. And what I need to take from this table is I need to take the number that we know, the item that we know both numbers for, both the percent and the other number. And right here, that is the new dosage. I know both the percent and the milligrams for that. And then I have to take the number that we are trying to find. And here, that's the previous dosage. And in order to find that, I have to have at least one of those numbers. And I do have its percent. So I can set up this proportion. Normally, we'd be used to 115 over 100, putting the 100 on bottom. But I don't have to pull this out and set up a proportion. What I can do is just this. I can ignore this middle row, and I can cross multiply and divide right in the table. I can do 100 times 920 divided by 115. Which is going to give us 800. So the previous dosage was 800 milligrams. Sometimes we might have the other side where we're not looking for the previous amount, we might be looking for the change. So let's say that a patient's blood glucose is down 12% to let's see here. 220 milligrams per deciliter. How much has it decreased? So again, I can set up a table. I have the old reading or previous reading, however I want to do it. I'm just going to say old reading. And it has gone down or decreased, so we're going to subtract that decrease to get the current reading, or I'm just going to call it the new reading. And like in all of our other problems, every item is described by a percent and another number. In this case, the other number is the milligrams per deciliter, which is just a common unit used for labeling blood tests. So here we have the 220. That is the new reading on the blood glucose. 12% is the amount of the decrease. But we also know that the old reading is where we started. That was the beginning value. That represents 100%. So we'll subtract. 100 minus 12 is going to be 88% is the new reading. Now notice that's different. This one was an increase, so we added the percents to get the new one. Here it was a decrease, so we took 100 minus that new percent, or that change to get the new percent. And now here we are looking for, we want to know how much it decreased. So we want to know how many milligrams per deciliter this decreased. So that's the number we're looking for. So in this case, we don't need the top number on the table. We have both numbers for the new reading, both the percent and the milligrams per deciliter. And we're looking for the milligrams per deciliter for the decrease, and we do have its percent. Now, we're going to ignore the negative here because that's just, it was a minus, not a negative 12. And we'll cross multiply and divide. 12 times 220 divided by 88. Should give us 30. So that is decreased by 30 milligrams per deciliter. There are a lot of other applications for these percents, but I'm going to take a look now at markups. If you get into the administrative side of the medical field, administrative side of any business, you're going to have a markup. Everything you deal with is going to have a certain cost associated with it. The cost is the amount of money that you put into it. If you're buying products and reselling them, that would be the cost of the product. And then, of course, your expenses, whether it's shipping or labor or whatever. And to that cost, you're going to add some sort of a markup. That markup is your profit and probably overhead. You know, you buy this product, yes, you have the cost of getting it, the cost of shipping. You have labor involved in taking that product and getting it on the shelves and selling the product. But you also have cost for your building, rent for your building, utilities, and stuff like that that cannot be directly linked to a single product. So that has to be accounted for in your markup. Then, of course, that's going to equal what we're going to refer to as the selling price. And that is your total. That's what the customer is going to pay. Now, in the medical field, there are supplies that are going to be cost, medications and stuff like that. The cost of the equipment, they figure equipment has so many hours worth of life. So the number of hours, of the life hours used off the equipment is going to get figured in. And labor, nursing care, doctors, orderlies, and other things that are put in. So those costs can be directly figured out. Markup then is going to be the building cost, the general maintenance cost of the building that's not directly related to any patient, janitorial and whatever, utilities and all of that. Any licensing and stuff like that must be maintained. So then, of course, they're going to add those together to figure out how much they're going to charge the patient. Because the medical side of this is so complex that there's so many variables, we're going to take a look at it from a simpler side of just a retail point of view, where you're buying a simple product, you're turning around and selling it for a profit. Most of the time, our markup is based on cost. So if you buy a product, so you purchase an item for $80, and you want to have a 35% markup on cost, how much would you charge? Or how much would you sell it for? So here's exactly the same as what we were just showing in that table. We have a cost. To that, we're going to add this markup. And we're going to get a selling price. So again, we got percents, and then this time our other number is dollars. We have the $80 is the cost. We have 35% is our markup. Now in this case, remember I specified markup on cost. What that is saying is the cost is considered the 100%. There are some cases in business where we do markup based on selling price. And the reason we do that is at the end of the week or whatever, we can just pull up the cash register sales and we can figure out what our cost is because we know the markup is a percentage of the sales rather than a percentage of what it actually cost. But we're going to stick with markup on cost because that fits what we've been doing. So we've got 100 plus 35 is 135 is our percentage of selling price. To find out how much you would sell it for, we're looking for that number. So we're going to ignore the middle here and we will cross multiply and divide. So it's 135 times 80 divided by 100. So 135 times 80 is 10,800 divided by 100, of course, will be 108. So you would charge $108 for that product. Okay, that's kind of a general overview of the applications of proportions and ratios and percents that I wanted to get into. I don't want to go too much further because we are missing 3 out of the 4 groups today. So what I'm going to do is just this. I'm going to give you page 78 1 through 35 the odds. And I'll let you guys have the last 15 minutes here to get started on those if you want to. Or if you do have other things that you need to go do and it's okay with, if it's okay with your school to leave the room, I'll leave that up to you guys.